Hello, ladies and gentlemen. Welcome back to Math 30-1, Chapter 2, Section 3, Part 2, Analyzing Rational Functions. Now, we've just analyzed this nasty diploma exam question, and yes, you're going to see it again. Going on, horizontal asymptotes. Now, last class we talked about horizontal asymptotes. These are pretty straightforward. Now, honestly, if you're given a graph like an equation like this, you can graph it. So please graph it for me. So pause the recording and draw the graph. Now we're back. So my graphing calculator says something like this. Now, remember, I do want you to be able to algebraically calculate the x-intercepts. The x-intercepts, y is equal to 0, so this is 0 is equal to 2x squared minus 11 over x squared plus 9. Now you're welcome to try factoring that, but good luck. So I multiply both sides by x squared plus 9, so that I'm canceling out my numerator and then just down to my denominator. Or sorry, I'm canceling out my denominator and I'm out to my numerator. Now I want to isolate x, so I would suggest adding 11 to both sides. 11 is equal to 2x squared divided by 2. And of course we're down to x squared is equal to 11 halves. Now what's x? Well, take the square root of both sides. X is equal to plus or minus the square root of 11 halves. Now if you're lazy, that's plus or minus 2.4. You can read that off your graph. If of course I drew my graph slightly better. Let me fix that. 2.4 is there, 2.4 is there. My bad. Now, y-intercept, much the same idea. Y-intercept, x is 0, so y is equal to 2 times 0 squared minus 11 over 0 squared plus 9, which is minus 11 over 9, which is approximately minus 1.2. Now, so far so good. So let's look at our non-permissible values of x. From our graph, there's no vertical asymptotes. And double check our denominator. X squared plus 9. Square root of minus 9, we do not take the square root of a negative number, so there are no non-permissible values of x, no vertical asymptotes. Now, horizontal asymptote, this does appear as though it's going towards 2. Now, you can check that on your table of values. Please do. However, you can also prove it, check it algebraically. Let me see, nice color I've used. X goes to infinity. Y is equal to 2 times x squared over x squared, which is 2. Works for me. Now, I want you to check this, or check your ability to do this. Go on, find for numbers 5 and 6, find the horizontal asymptote algebraically and check graphically. Now, pause the tape, try it algebraically, then graph it. When you've done that, continue the recording and check your answer. Pause. Okay, now that you're back, I'm assuming you've got it. And so here, x is going to infinity. This will be y equals x over 2x. Remember, we're just looking at the highest power, which is 1/2. So we should have a horizontal asymptote at x equals 1/2. When we draw the graph, we get something like that. My apologies, ladies and gentlemen. Now notice we do have a vertical asymptote, but that was the last section. I'm not concerned about that now. And yes, it does look like there's a horizontal asymptote there. So, if you've got that, go on to part number 6. Do the exact same thing. Pause the recording now. Check it. If you've got this, go on to the next part. Okay, so here, x is going to infinity, so this becomes y is equal to 3x over x squared. Remember, we're only looking at the highest powers, which becomes 3 over x, which becomes 3 over infinity, which is 0. So when we draw the graph, we get something weird like not my best drawing, but you get the idea. And when you look at it, you're going, yes, it does look like there is y equals 0. It's a horizontal asymptote there. Okay. Now, that's it for this section. If you have any trouble with this, go back, look at the examples again. When you're ready, go on to the next part.